Okay, so we're going to use what's called the rational zero theorem, and I thought it would be helpful to just do a review of rational numbers. So you have integers. Integers are numbers like, -3, -2, -1, 0, and you can go, in the negative direction off to negative infinity. 1, 2, 3, and on up to infinity. I always think of them as the numbers when you're drawing a number line. They're often the little marks that you make to count on the number line. Okay, so those are integers. Rational numbers are anything that can be written as the quotient of two integers. So a lot of times people just think of fractions, 3/4, that's a rational number. 1/2, that's a rational number. You could do a decimal, like 0.25, because that could be written as 25/100, which could be 1/4. And you can have them be negative as well. So, that's just kind of a brief review of rational numbers. All right. The rational zero theorem says this. If you have a polynomial, and we've written polynomials in this form before, and I'll just shorten it up. So you have it in standard form, your highest exponent first, that n is the degree, right? The degree of your polynomial. And then we're going to say that a n through a sub 0, that those are all integers, or they're from the set of integers. So integer coefficients. Integer coefficients. And then what we're going to do is we're going to say P is a factor of a sub 0, and Q is a factor of a sub n. And then what we're going to say is that if you take P over Q, then you're going to get the possible rational zeros. Possible rational zeros. It doesn't tell you what the zeros are, but it narrows down the selection. So let me give you a little example here real quick. Let's say you have f of x equals 2x to the 4th plus 3x cubed minus 7x squared plus 8x plus 6. Okay. And you want to find the zeros for that polynomial. It's kind of long, right? Like you're not going to be able just to guess them. If you tried all the numbers, that would take like a long time. So what we're going to do is we're going to look at P as factors of 6. So factors of 6, what do we mean by that? Any number that will divide evenly into 6. So 1 is always a factor. In fact, plus or minus 1, because it could be negative, plus or minus 2, plus or minus 3, and plus or minus 6. Those are all factors of 6, okay? And you're always going to include the plus or minus when you're using the rational zeros theorem. Okay, then we're going to go to Q. What are the factors of 2? So this is Q. It's based on that coefficient. Factors of 2. Well, plus or minus 1 and plus or minus 2. That's it. That's all we have. Okay, so now what we're going to do is we're going to take each factor of P over each factor of Q. So I get like 1 over 1. See, that's the first one, right? And 1 over 2. So like I'm going 1 over 1 and 1 over 2. I'm not going to keep drawing these arrows. And then I have 2 over 1, 2 over 2, 3 over 1, 3 over 2, 6 over 1, 6 over 2. And it doesn't usually take this long, but I'm trying to write it all out so you can see I'm putting a factor of p over each factor of q. Okay, so each factor of p goes over each factor of q. Now I'm going to simplify. 1 over 1 is 1. 1 over 2 is going to be 1/2. 2 over 1 is 2. I don't need this because I already have the 1. 3 over 2. 6 over 1 is just 6. And 6 over 2, I don't need that because that's 3 and I already have it. I make them all plus or minus. And then I probably should put commas between them. But okay, oops, I don't need that last comma. Okay, that tells you these are all the possible rational zeros. You might be saying, well, what about the irrational ones? Well, it doesn't say anything about that. It just tells you the possible rational zeros. So there are how many? 1, 2, 3, 4, 5, 6. There are 12 possible rational zeros here. Okay? That's what the rational zero theorem says. It doesn't tell you what the zeros are, but it's very helpful because now instead of trying all the numbers in the world, we can just try these 12 and see if any of them work. Okay, and we'll show you how to do that in some examples.